So when we take a look at this equation, we can't solve it in its current state because we have both the cosine function and the sine function. And if we have two trig functions in our equation, we are not going to be able to solve like that. Okay? So we're going to have to either get this cosine squared x to be in terms of sine, or we could get the sine x to be in terms of cosine squared x. Now, from your experience with simplifying, hopefully you realize it's usually easier to relate the squared term with the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. So I can say that cosine squared theta is the same as 1 minus sine squared theta. And so that's what I'm going to do. I'm going to do a substitution. And I'm going to replace the cosine squared theta with 1 minus sine squared theta, or in this case x, and bring everything else down the way it is. Alright, so from line 1 to line 2, you can see the only thing that changed was cosine squared x was replaced with its equivalent expression, 1 minus sine squared x, and that came from a Pythagorean identity. Alright, that's the big part. Now we're just going to distribute the 2. Bring everything else down. So what did we do? We distribute the 2. Okay, next we're going to combine like terms. You'll see we have a 2 and a minus 1. So we're just going to combine those down at the end of this expression and have plus 1. So I combine my 2 and my minus 1 to give me a plus 1, combining like terms. Alright, and then we want to factor this, and the first part of the factoring is I'm going to factor out a negative 1 so that my leading coefficient is positive. So I'm going to have negative 1 times 2 sine squared x plus sine x minus 1. So I've factored out the negative 1. So everything here now has the opposite sign that it had. Now I'm going to take this expression, which this expression here is a trinomial. I'm going to break it down into, factor it down into 2 binomials. And so in order to get 2 sine squared x, I'm going to need to have a 2 sine x multiplied by a sine x. And in order to get a negative 1 as my third term, I'm going to need to multiply a positive 1 times a negative 1. But my middle term is positive, so I need to have more positive, so the plus 1 needs to go here, and the minus 1 will go here. And so now I have factors being multiplied together and equaling 0, so therefore one of my factors is 0. Well, negative 1 isn't 0, so we're done with that. But 2 sine x minus 1 may sometimes equal 0, or sine x plus 1 may sometimes equal 0. And then we'll solve these 2 mini equations. So 2 sine x would equal 1. Sine x would equal a half. So I can go to my unit circle, and when is sine equal to a half? Well, right there at pi over 6. And then remember, sine is also positive over in the second quadrant, so that's also there at 5 pi over 6. So x equals pi over 6, 5 pi over 6. Now I come solve the other little equation. Subtract 1 from both sides. Sine x equals -1. So again, going to my unit circle, when is it that the sine x is equal to -1? Sine x is -1 at 3 pi over 2. So those three values represent the solution to this equation. Alright, anybody have a question about one of those steps? Alright, then let's move on to our second example of the day. And for this one, we're going to be looking at the strategy solve by squaring. So we're starting with the problem, cosecant x minus the cotangent of x is equal to 1. Now, you might say, well, Ms. Carter, why don't we just do what we did in the last problem and try and get these down to just one trig function? Well, yes, that actually would be a lovely idea. But if you look, there is nothing that relates cosecant with cotangent, right? If you start rewriting these, you're just going to end up with more trig functions. But look down here. In the Pythagorean identity, there is something that relates cotangent squared with cosecant squared. So I'm going to take this Pythagorean identity and write it over here on the side because we're going to be using that. So right off my sheet, it says cotangent squared theta plus 1 equals cosecant squared theta. So if I can get cosecant by itself, then I could square it and turn it into an expression that has cotangent. Following that logic? So I want to go back to my original equation here, and I want to do what I can to get cosecant by itself. So I'll add a cotangent of x to both sides. I'll then have cosecant x equals 1 plus cotangent x. And now at this point, I'm going to square both sides. Again, there is no indication looking at this that is what you should do unless you've got this Pythagorean identity in the back of your mind, right? You kind of have to have an idea of where you're going. So, we're just going to come in here and square this, and then square this side. Okay, cosecant of x squared, let's make sure we all understand this notation. Cosecant of x, like this being squared, is the same thing as cosecant squared x. These two things mean the same thing. It means the entire cosecant being squared, not just the x. So I can now take this expression, which is the same as this, and I'll replace this side with cotangent squared x plus 1. And I'm just going to bring this guy down for a moment. Oh, this is not squared. My bad. Square's over here. Okay, so look at what we've done. We've taken this expression, cosecant squared x, and replaced it with this expression, which came from this Pythagorean identity right here. This is the Pythagorean identity that allowed us to do that. Alright, so now I need to take my right-hand side and I need to square it, and I want to caution you that you do not just square the 1 and then square the cotangent, right? That is mathematically wrong. You can't just distribute that little 2. The quantity 1 plus cotangent x means 1 plus cotangent x times another 1 plus cotangent x. I'm just going to bring this guy down. So we're going to go ahead and multiply these two binomials. 1 times 1 is 1. Cotangent x and another cotangent x, that'll give us 2 cotangent x's. Cotangent x times cotangent x will be cotangent squared x. And just bring this guy down again. Alright, now we're just going to do some algebra. I'm going to subtract cotangent squared x from both sides. And then at the same time, I'm going to subtract 1 from both sides. And I'm going to have 0 equals 2 times cotangent of x. I'll divide by 2 and I'll have 0 equals cotangent of x. And then this is where it will be very handy to grab that chart that we made last block. This is my one from B-Day. It's a little bit different. So I've got cotangent, and I want to know when the cotangent is equal to 0. Cotangent of 0 at pi over 2. Right? But I have to remember that that little chart we made was only for the first quadrant. So the cotangent is 0 at pi over 2 because cotangent is cosine over sine, and cosine is 0 here. But also look down here at 3 pi over 2, then we'd have 0 over negative 1. So we also need the 3 pi over 2 value. And that's it.